Let's take some time and try to understand some of the most common or very commonly used terminology that you must know in machine learning. We will cover a bunch of terminologies basically and try to understand what they actually mean. And the very first one that we are going to see is supervised versus unsupervised learning. Very basic, very common terms. What this basically means is it refers to the type of a learning algorithm, a type of learning a machine learning algorithm does. Supervised learning versus unsupervised learning. Certain algorithms are supervised, certain other algorithms are unsupervised. Now, what is common between both these types of algorithm is both involve some sort of pattern learning. Some sort of pattern learning is involved. This is the common part. But the main difference is in supervised learning, you will have a label variable. You will have a label involved in your training data set. What do I mean by that? Now, in our housing price prediction problem, in that problem, we had one of the columns, one of the fields in the data as housing price, probably in dollars, right? So you have one of the fields as housing price. Your objective here is to make the prediction for housing price. So this Y here, the housing price is the Y. This is what we also call as label. So given certain input X, you want to predict the Y. Whenever this label Y is present, you can safely call that particular algorithm as supervised learning algorithm. Now, if this label is not present, let's imagine a case where you have the features of various different houses. Each and every row in the data set represents the various features of the houses. All right. You don't have a Y. You might even have the housing price, but we are not focused on predicting the housing price. Housing price might be considered as just one other feature present in the data. If that is the case, and you just want to do some sort of a pattern understanding about this data, we will see certain examples of that. If there is no guiding label behind it, there is no concept of label in your data set, then that particular algorithm is called unsupervised learning. That's the main and the only, probably the only difference. Now, just to summarize, the label here acts as the supervisor, right? In your algorithm, you have an input and you map it to an output Y. In the learning of the algorithm, this output Y acts as the supervisor on how to actually map this input to output. So this Y is also called, it's not generally called a supervisor, it's acting as a supervisor. We don't call it a supervisor. It basically guides how the ML model itself should be formed. Now you might be wondering, we saw the example of housing price prediction was a supervised learning algorithm. Now, what would be an unsupervised learning algorithm when there is no Y involved? A typical example, let's see three different examples. One example is clustering. You have your input data, right? You have your data where you have various fields, various information about each of the houses. Let's imagine this to be the data. We have the area of the house, location, zip code, all these different aspects of the house is present. Let each row represent a house. Now, we just want to group similar houses together. If that is the case, we call that particular problem as a clustering problem. We want to form logical groups within your data. That is clustering. What is recommendation system? Now, before going to that, in clustering, notice we don't need a Y variable. We don't need a label variable. This is not needed. This is not at all needed. The housing price itself can be present here, but the objective is not to predict the housing price, right? We just want to group these houses, and we might want to group the houses based on the housing price also. So there is no concept of Y. All of this data is input data only. There's no concept of label Y. So that is clustering. Now, what would be recommendation system? Now, imagine you have another data set where you have various users. All the different rows are users, U1, U2, U3, U4, and so on. So you have various users, and the houses being rated by each of these users is also present, and that is present in columns. Let's imagine all these columns are houses, house or properties, whatever. And the users have given some sort of a rating for these properties, right? And you want to recommend to a user what sort of houses he or she is going to be interested in. That would be a recommendation system. Also notice in this particular case also there is no concept of a label. The label Y is not present here, right? So this is also a unsupervised learning problem. Another example is dimensionality reduction. Now you have this data. It could be any data. It could be the house information itself. Say this is your house information. And let's imagine that we have about, say, 200 different fields are present. 200 different fields are present about each of these houses. A lot of different variables or columns are present, right? Now we want to represent that information in that column into much fewer columns. That part, the part of reducing or efficiently representing the data present in a given data set in fewer columns. We are not going to filter out the quantum of the data itself. We just want to represent the data in fewer columns. That problem is called dimensionality reduction. Maybe the information contained in 200 different columns can be more efficiently represented, say in 20 columns. This 20 columns might not contain all of the information from 200 different columns, but it might contain, say, about 80% of the information. That is still possible. The core information contributed by all the columns present in the data set, that is the majority of the information from the 200 columns data set, can be represented efficiently in with just 20 columns. I'm just stating an example. This could be 10 columns also. This could be 50 columns. But the idea of reducing the dimensionality so that most of the data is represented can be a dimensionality reduction problem. And this is also not involving any label here. No label is involved. So this is also a unsupervised learning.